So first, we're going to just define some things. You guys should know these, but let's just ask what they mean. If I talk about an acute triangle, what does that mean? Yes.
The angle is, there has an angle that's smaller than 90 degrees.
Is it just one angle? What's the definition of an acute triangle? Yes.
All of its angles.
All the angles are less than 90. So here, all of the angles are less than 90. A lot of these we see all the time, something like, I have to make, oh, that's not gonna work. Okay, I'm just gonna do it like this. Okay, something like that where that's supposed to be less than 90. Okay, so those are acute triangles. An acute angle, yes, is one that's less than 90. So what you guys were talking about, I just added triangle instead of angle. Okay. So the next thing is a obtuse triangle. So it obviously has an obtuse angle, but how many obtuse angles does it have? Yes. One. Why can it only have one?
It's not possible for all of them to be obtuse and it still be closed.
Okay. And is it possible to have two obtuse angles in a triangle and it still be a triangle? No, because two of them over 90 would make more than 180. And so that's why. So there's only one of the angles is more than 90 degrees. Okay. And then the last one, which should know, is a right triangle. We talk about this quite often. It is one of the most used triangles that we have, especially because we like to build things that are square or on squares that are perpendicular to, like our wall is perpendicular to our ceiling. So we use this a lot, okay? What is a right triangle? Yes?
As 190-degree angle.
As one. Why does it only have one? Blake, why does it only have one?
Because if it had multiple, it couldn't be a triangle.
That's correct. Okay. Okay, because if I put 90 and 90 together, that's 180. What happened to the third angle? We have to have three angles in our triangle. Hence why it says tri, like a tricycle, three angles. A triangle has three angles. That's why how it's named triangle. Okay. So those are some basic definitions. And then that's based on angles. So this is how we classify. This is based on angles. So we can call a triangle something based on the angles. We can say it's an obtuse. You know that there has to be one more than 90 degrees in that. So if I tell you I have an obtuse triangle, you know one of the angles has to be more than 100 or 90 degrees. Okay. We also classify them based on sides. Okay, there are three types based on sides. Does anybody want to give me one? Do they know any of them that are based on sides? Besides Paxton, who else knows? Aaron, do you know what one of them is called? It's okay to look up.
We're talking about like scaling.
Yes,
Yeah.
scalene. What does scalene mean? A scalene triangle, what is true about a scalene?
If it has no equal sides.
Yes, not all the sides are different lengths. That's the easier way. All the sides are different lengths. I like to write it that way because it gets confusing saying no sides are the same. I mean, I guess that's another way of saying it, but all of them are different. Okay. Okay, that's what it really comes down to. What's another kind that we have? Harrison, do you know what's another kind?
No.
You don't, okay. Luke, do you know another kind? Micah, do you know another kind? Yes.
Isosceles.
Yes, isosceles.
And isn't that where like two of the sides are the same?
That's correct. Isosceles has exactly two sides that are the same. So it has two sides that are the same. Okay, and we're gonna be working, see the title of this, isosceles and equilateral up here? We're working with isosceles today. Okay, so that's one of the ones we're gonna talk about. What is the last one?
I don't know the name, but it has all equal sides.
Yes, and look up at the board. Do you think you can see what it might be? Harrison.
Equilateral.
Equilateral. And that just fell. So I don't know if you know what a lateral pass in a football is.
Isn't it
Anybody know?
to the side?
It's to the
Oh.
side, yeah. It's usually to the side. Okay. This really means side. That's why you hear lateral in football, because it means pass to the side. This is equal. So what do we get? Equal sides. Okay, that's what equilateral means. Okay. That means that all sides are the same. Okay, so those are the different types of triangles and how we can categorize them based on either angles or on size. So this is really the categories of triangles. Okay, there are not really any others. We talk about right triangles. We use right triangles all the time because we have Pythagorean theorem. We go in, when you go into trig, you will be dealing with right triangles. That's what trig is based on. We deal with acute angles all the time because that seems to be one that is used quite a bit. Well, because the acute and obtuse go together a lot of times in a linear pair. So you use acute and obtuse quite often. And so scalene is a lot of right triangles are scalene. They don't have equal sides. All the sides are different. Isosceles is one that we use quite often. It's used to make patterns and stuff, isosceles triangles. Equilaterals are also used to make patterns when we're looking at patterns. Equilateral triangles actually can be made into a mosaic where there's no empty page, no empty space on it. Because if I do an equilateral triangle, then I can put them together. I know this doesn't draw right, but I can put them together. There's never any space around them. So I can make a design where there is no space around an equilateral triangle. You can't really do that with scalene. It's harder, you can do it, but this is easier. I'm trying to show that those are all equal. Okay. Again, remember my drawings are never good. So that's, you should know how to classify. You should know what an acute triangle is, an obtuse, and a right. You should know a scalene, an isosceles, and an equilateral. But you now have them in your notes. So if you're taking a test and you forget, go back to your notes and look at our definitions. That's why we take notes. So in case you forget what it means, you can go back and look. So let's see what is true about some of these triangles. We're going to do it using some drawings like we did yesterday. Okay. So I want you to right now just take a piece of paper, extra piece of paper. I have some plain paper. I don't know if I have very much. Yeah, you can use these. I printed these out, but I'm not using them. So use the back of these. Kind of going to do the same thing we did yesterday. We're going to look at drawing some that are isosceles triangles and equilateral triangles, and we're gonna see what we can find out. Okay, so right now, I want everyone to draw an isosceles, triangle. Okay, I'm gonna tell you, when you have an isosceles triangle, it's not always that it's an acute, but basically draw it so that your two equal sides are coming down like that. Okay, so you're making basically two equal sides. You don't have to measure a specific angle, you just have to draw one like that.
Right, you just need two equal lines and
You
just
need
connect
two
them.
equal lines and then connect it and make a triangle. Mark it similarly to this. You should have the two sides that are equal marked. I'm gonna make it A, B, C, and I'm gonna make the triangle there. I just want you to draw two that have two identical sides. Doesn't matter what the angle in between is.
I accidentally drew in, because I measured the angle and did 60 degrees and I accidentally did it equilateral.
Yes, you made an equilateral because it's 60, yes. You can keep that one for the next assignment. The next one we're gonna draw. Okay, while we're drawing, let's see, Blake, did you turn your test in? Did you turn that in, Lucas?
No,
Do you have it?
I'm not.
Yes, sir.
You're not done with it. When are you planning to finish it?
Today.
Do you have somebody to proctor you?
Yeah.
You do, okay. And are you sending it then
Do you
via
want us to
email?
measure the angles?
I want you to measure all three angles right now on yours. Who else came in? Paxton, you turned your test in, I asked that. Aaron? Luke?
No, I did not yet.
You're
Yeah,
not
I'm
yet.
finished
Luke, you have turned yours in, okay. So Blake turned his in, so we have three people right now, I'm waiting, and Lene is turning hers in, and who else is missing?
Two sides are equal.
I'm missing two people. Who's my other person missing?
Dude,
Dave, that's correct. Thank you. Okay, so when you go ahead and measure all three angles, mark their size inside. An exact 90, that's fine. Yep, so what are the others? Yeah, then what are the other angles? Measure your angles now.
And then what do you do once you're done measuring all that?
I want you to tell me, what did you find? What do you see? What do you see?
it's technically still almost equilateral. Mine is equilateral and isosceles. Wow, that just kind of a big price. But I like how he said, well, how do you make it not equilateral?
You go your clothes and.
You make it like, you can make it like really
It's
obtuse or something.
really simple actually.
All the sides are equal.
Yeah, equilateral. So we're just.
Okay, so my question is, how would you so what did you find is what I'm looking for, but finish the statement. If you have two sides equal, basically an isosceles triangle, then what is true? And what is true? Can you see anything about the angle that's true?
two equal angles?
Yes, there's two equal angles.
Oh, that's true.
Then two angles are equal. And how do I find which ones they are? Which ones are the two equal angles? Yes.
They're like the opposite of where you drew the two sides.
Okay.
Where they split,
So they're
basically.
not, this is called the apex angle in a triangle. It's the one up on top. And when you're drawing an isosceles, usually you put the apex up on top, and these are two called the base angles. The base angles when, okay. Or we could say it's the angle made by one side, the angle made with one side, angle with one side, one of the equal angles. Okay, so basically what you find out is if these two sides are equal, then these two angles are equal. And that's true. That is a theorem that's said to us. We can prove that. We just kind of showed it. We didn't prove it because we just did examples, but we have shown it to be true by our drawings of triangles. Okay, yes.
Should we be writing down all the theorems?
Yes, you should write this one down. I don't care if you know what this is called, okay? What I
In the
care
book,
is
it
that
just
you know, if you have two sides that are equal, basically in a triangle, that's an isosceles triangle, then two angles are equal. These are the base angles, or the angles that have one side of the equal sides, okay? So does that make sense? You can identify equal triangles or equal angles when you see equal sides. Okay. So that's the first one. Oh, a question. If I went the backwards way, what if I have two angles? Let's say I started with two angles that are the same in a triangle. What do you think would be true? Does it go the other way? Yes.
I would say probably, yeah.
Yes. The two sides, the opposite sides, these are called the opposite sides, okay, are equal. Okay, because this is directly across from this angle. So we call this A, B, C. This side, which is normally called little b, across from A is little a, and across from C is little c. That's how we name a lot of our sides. So the opposite side is, or the side opposite the angle is named with the little letter of that, okay? And so here, it also works vice versa. Everybody know what that means? I can switch it. If you want the technical term for this is a, oh my gosh. Now it just went right out of my mind. It's yeah, they call it Theorem 9. Isn't that nice? They call it Theorem 9. So believe me, I had to memorize them as Theorems 1, 2, 3, 4. Do you think that made any sense to me? No. Oh my gosh, I cannot think. Well, it'll come back to me. I can't think of what it's called right now. So, okay, so that's an isosceles triangle. So either way, if you have two sides that are equal, then the two angles opposite them are equal. Or if you have two angles that are equal, then the sides opposite them are equal. So that's something you can always tell because that's always true. Okay, so when you're looking at a triangle, if you're given two angles equal, you know the two sides are equal. Or if you're given two sides are equal, you know the two angles are equal. Either way around, that works. Okay, so let's now check for an equilateral triangle. I think, was it Lucas that already drew his equilateral triangle because he made it that way? Okay, so I want you to draw an equilateral triangle. Now what you might do, this is harder to draw, Okay, does anybody know, just guessing, what the size of the top angle is? Yes.
60.
Yes, the top angle is 60 degrees. So make a 60-degree angle with two sides that are identical length. So this is going to be a 60-degree angle. These are going to be the same. And then finish it and measure. This is going to be the same then, should be. Measure the base angles. That's the other two right there.
So sketchy. Why do I feel like you should be very different?
And then complete the statement that I just wrote up there. If an equilateral triangle, then what is true? Based on your drawing, then what is true?
Same.
Very true. They're what? They're all congruent. What else size are they?
Draw 60.
What is the size?
60.
Yeah. Hopefully you're practicing measuring these and not just going with, oh, I know what this is, because that's part of this class is learning how to use our protractors very well. The compass and straight edge we'll learn. I'm not going to be as picky on that just because I'm not really sure how often I've ever used them, to be honest. But we do use protractors. We can also, we're going to show you that you can actually use different things to measure angles. Part of that I think is in your homework that you have. I'm not sure, I remember seeing it. Okay, what did we find out? Who would like to tell me what they found out? Jake?
All sides and angles are equal.
All sides and angles are equal. And we can say one other thing. What can we say? Yes.
Congruent.
Well, all angles are congruent because they're equal. What else can I say about them? Do I know their size? What was your size of your angles?
My sides?
Yeah, size. What was the size?
It was 4 centimeters. All sides are 4 centimeters.
No, the angles.
60 degrees.
Okay, Luke, what were yours?
60.
Micah, what were yours?
75.
You haven't found it yet? Okay, Elijah, what'd you find? 60. Everybody got that their angles were 60 degrees. No, you didn't. What did you get?
59, 61.
Well, I'm going to say that you just measured a little inaccurately.
Yeah.
Okay, so all angles, you can also say this, are equal and are 60 degrees. We can actually know that every time I draw an equilateral triangle, it doesn't matter what the size, you are going to get 60-degree angles. Okay, that will be true. And so it's not that they're just equal, but they're all 60 degrees. They're always 60 degrees. You will never have an equilateral triangle that does not have angles that are 60 degrees. So that's something that you can use when you're looking at drawings if you're trying to figure out what are the amounts of this or that. You use those ideas. That's what we use all these theorems for, is to be able to figure out, how can I figure out a certain angle if I'm looking at it, okay, or a certain length of sides. And so that's what we're looking at there. So that's basically 4-5, okay. So 4-6 is about one other. Remember, we have two ways of saying if triangles are congruent so far. So in 4-6, it's another way, but right now we have two ways for finding congruent triangles. Okay, so one is SAS. What that means is if you have two triangles that have two equal sides and the enclosed angle, the angle between, then they are congruent. Okay, so this basically says two sides are equal and the enclosed angle is equal, then triangles are congruent. So it's actually pretty easy because it tells you side, angle, side. SAS, side, angle, side. If I have a side, an angle, and a side that are both the same in both triangles, then they are the same. The other one we looked at in 4-4 or 4-3, whichever one it was ASA. What did that tell us? Let's see. How about Lucas? What does ASA tell us?
I forgot.
Look at it. If two angles
And a side
and a side, what does the side have to be?
between the two.
Yes. So if we have two angles that are equal and the side in between the two angles is equal, so it's two angles are equal and the side between the angles is equal, then the triangles are congruent. That looks like this. If I have a triangle like this, it's not meant to be equilateral, but if I have that angle is congruent to this angle is congruent to this angle, and this side in between, then they're congruent. Okay, so that's what we've learned so far. We are going to learn one more thing that proves triangles are the same. And this one is called SSS. Now, based on what I just wrote, what we talked about before, what do you think the SSS thing tells us? Yes.
That if all three sides are equal, then they are congruent.
Then the triangles are congruent. That's exactly what it says. Okay, so this says if all three sides are congruent or are the same, then the triangles are congruent. Okay, so this is kind of like if I had something like this. Let's see if I can draw it. Well, they're not the same, but we're going to pretend they're the same. All of that, they would both be equal. Okay, so we're gonna kind of show this. We're gonna do on that paper that you had out before. We're gonna show that, but this is what we're really just adding this one for congruence. It's another way to show that if you know that all three sides are the same in the two triangles, then those two triangles are congruent. So that's something that we're looking at. Okay, so on what I'm going to do is again, like